This video is about the variation with and without repetition. To understand this, we use the urn model. So for this, consider an urn or a box where balls numbered from 1 to n are contained. So from 1, 2 until n. And we draw k balls from the urn with n balls. The ordering is important, so we say, okay, there is the first place, the second place, the third one until the kth place. So on the first place, the first ball is drawn. So here is the first ball, and so on. So we have to distinguish two cases. The first case is with replacement or with repetition. So what does this mean? This means you draw a ball and put it back to the urn. So the original experiment has not changed. So I try to explain this by using numbers, small examples. So let's say we have an urn with 5 balls and we take out 3 balls. First is with repetition. So what does this mean? How can we describe one draw by a so-called 3-tuple? For example, the first ball is the ball with the number 2. The second drawn ball is the ball with the number 4, and the third one is the ball with number 1. So since you can repeat, it means you can take the first ball, the fifth, and you can take the ball with number 1 again, because we have replaced. Or 2, 2, 4 is another example. Or you can also draw 3 times the same. So you draw ball number 3, 3, 3 again and again. So how can we describe this in general? This is described by the set variation of n balls taking k. And with repetition, so we use a small index r, subscript r. How to describe it? So instead of a 3-tuple as here, in general, we take out k balls, so we have a k-tuple. And each x1 or x2 can be a number from 1 to n. So the numbers of the balls. So a very important question is how many k-tuples, so in our example, 3 tuples, are there actually? So for this we have to compute the cardinality of this set variation with repetition. So for the first place here, you have n different possibilities. So because there are n balls available. You replace the ball, so you don't change the experiment. And for the second place, you also have n different possibilities. And so on, until the last one. So this is repeated k times. So we can rewrite this formula as n power k. We have to multiply each possibilities because we have to combine. So the second draw has to be combined with the prior possibilities. That's why we multiply. So what does this mean in this example? We have 5 balls and we draw 3 times, so we have 125 different possibilities to choose 3 out of an urn with 5 balls with repetition, with replacement. So the second case we have to consider is without replacement or without repetition. So this means you take out the ball and you keep it outside. The drawn balls remain outside. So let's do examples here on the right side again. So without repetition. So it can be 2, 3, 1 or 5, 1, 4, 1, 4, 3. So you see what is not possible is 2, 2, 4. You are not allowed to repeat numbers, or 3, 3, 3, or 1, 5, 1 is also not possible. So how to describe this in general? So the variation, we don't need an index because we do not repeat. We again have k tuples. So this is the same as above. We have n balls in the urn. For each draw we can have a number from 1 to n. But in addition we have a constraint, an additional condition. Because x1 is different from x2 and so on. You see here, there cannot be like 1 for 1. So in math we just write here pairwise distinct or different. Pairwise distinct or different. So it just means if you consider, for example, 5 and 1, it's different. 1, 4 is different, 5, 4 is different. So it means no repetitions. So what is the cardinality? This means we compute the number of possibilities in the set of variation without repetition. So for the first place we have n different possibilities, but you have now drawn 1 and you keep it outside. So for the second one, only n minus 1 remain, because 1 ball remains outside. For the next one, only n minus 2 different possibilities to choose from the urn, because 2 balls remain outside. So until what is the last one, this is the tricky part. We know we have, altogether we have k factors. So everything together, I think you cannot see here anymore, but k factors I want to write here. So this means here the first one, n minus 0, actually there is 0, so we start counting at 0, 1, 2. So the last one is not n minus k, it is n minus k minus 1, because we start counting at 0. And we have k factors all together. So how to express this briefly? N factorial, but you don't go down to 3 to 1. You only go to n minus k minus 1. So you have to cancel out n minus k factorial. If you do not believe this formula, just write out what does it mean, n factorial, and then you will see that this is the same. So this means instead of n factorial, you can write n times n minus 1, blah, 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 until here, and then times n minus k factorial, which cancels out. So we have to consider 2 particular cases. So that's why I have deleted this example. So in particular, what if is k is equal n? So what does this mean? I take all of the n balls out. And in addition, I do not replace. So VNN, I do not replace as the second example. And I take all balls out from the urn. So the cardinality, you can use the formula what we have derived right now, n factorial. n is equal k, so what remains is 0 factorial, which is 1, so the formula is n factorial. So what are standard examples for this? For example, we can consider a pearl necklace. So with different pearls, like this is pearl number 1, 2, 3, until the last one, which is n. And this describes the number of possibilities how to arrange the n pearls. And you have n factorial different possibilities to arrange the pearls on the necklace. Or you can also think of books in a shelf. 1, 2, and here you have the last book n. How many different possibilities are there to arrange the books in the shelf? N factorial. Or you can think of a river like Danube. How many different words you can form using these letters here? Maybe the words are meaningless, but how many different words you can form? You have how many letters? 2, 4, 6 letters. So we have 6 factorial words you can form. So I used a calculator and we have 720 different possibilities. And because this is so important in practice, this has an own name, and this is called permutation. Permutation. Without repetition. So in practice, if people speak about permutation, it just means you take all balls and you think about the different arrangements. So I had to create some space here because I also want to have a look at the last special case. It's the permutation with repetition. This actually has nothing to do with these variations right now. And that is why we look at this just by using an example. And we consider another river, not the Danube. We consider the river Mississippi. You may ask why this river? Because this word has 4 S, 4 I, and 2 P. So many letters are repeated. The question is, how many different words, mostly meaningless words, can you form with these letters? So altogether we have 2, 4, 6, 8, 10, 11 letters, and you can permute them. So 11 factorial. But that's not the truth, because the 11 letters are not different. You can permute actually the letters S. We have first S, second, third, fourth. Among themselves. And how to permute the S? Using permutation. Using permutation. So this is S1, S2, S3, S4. They are actually the same. If you permute them, you don't change the word. So this means we have 4 factorial possibilities we have to cancel. We have to reduce these 11 factorial. So we have to cancel by these 4 factorial permutations. And the same you do for P and for I. Again, for I we have 1, 2, 3, 4. So if you interchange I1 and I2, it doesn't change the word. So you reduce by these 4 factorial coming from I, 2 factorial coming from P. And if you want, you can, for completeness, write 1 factorial, which is 1 for the M. So how does this look in general? The formula, we have n letters, and the n1 letters are the same, so we reduce by n1 factorial, and 2 letters are the same up to nk letters are the same.